Two students. Who would have thought we'd be ending the year with yet another video? I know I didn't, but this is where we're at, and so let's finish things up. What I want to talk about today is the daylight data that you collected and try to help get you ready for your summative so you're thinking about the right things with it. So first of all, you went to this website that you can see I have pulled up behind me here, and you gathered data. You recorded it in this table, and notice we just recorded it every 2 weeks. We did not record data for 365 days of the year. Okay, and we recorded it in minutes. And then you ended up with a scatter plot. And so let's look at some of the questions that go with this scatter plot. So first thing you want to consider is what is the maximum amount of daylight and the minimum amount of daylight. Now, I can see that the maximum is happening somewhere here around day 175, and the minimum somewhere around the end of the year, 357. So what I chose to do is I went back to this website, and I saw that, oops, let's drag this over here. If it's happening near the end of the year, that would be December, okay? And I went to December and I actually scrolled through the data and I wrote down what is the minimum amount of daylight. And I saw that that happened on December 21st, 8 hours and 46 minutes. And then this would have been the halfway point. So if I'm at December, halfway before that would be June. And if I scroll through here just to make sure I didn't miss this point in my table, 1537, this right here, June 20th, looks like the most daylight. So we have our days, we have our amount of daylight, and now what's significant about these days? What's significant about the dates of June 20th and December 21st? And I'm going to leave you to think about that. All right, let's move on to K, the vertical shift. Okay, so I used my sliders and I found a good fit for my data, and my vertical shift ended up being at 731.5. That's where I got the best number. And what I used my sliders to figure it out. But then what I was also noticing here is this vertical shift is intersecting my graph right here, right in between my maximum and minimum point. So if I head back over to my data to take a closer look at that, well, right in between June and December is September. And if I look at what's happening in September and the amount of daylight, what I'm seeing is 12 hours in all of these. So I'm seeing about 12 hours around September 24th. And if I go the other direction and look at March, if I go to the middle of March, I'm also noticing that. So what's significant about these days? What's significant about these days near the end of March and the end of September? What's special about them on our calendar? And again, I'm going to let you think of that. Next is the amplitude. Well, we know that to find the amplitude, you take your maximum value minus your minimum value, divide it by 2. Okay, so we're able to figure that out very easily, 205.5. Okay, so that's how I did it. So what connection does that have to K? Well, if we're looking at K as our 12-hour mark, what does the amplitude say about that? Above 12 hours and below 12 hours. Next up, what is the period of the graph? What is the length of time for it to go from minimum to minimum or maximum to maximum? So what's the number of days to go from maximum amount of daylight to maximum amount of daylight? What are the number of the days from June to June? You know this. I don't have to tell it to you. Now remember though, the period is not B. What B is, we'll write it down right here. I'll try to do some typing. Okay, remember, the period is equal to 2 pi divided by B. So if you know what your period is, you can now solve this equation for b, and you can put that into your function. And what does the period mean in the real world context? So now we're bouncing back to period, the distance from maximum to maximum. What does that have to do with daylight? Last one, the phase shift. Now this is going to be different if you chose to use a sine function or a cosine function. So I can't really guide you as directly with this one as with the previous ones. But what I'm noticing, sine typically starts at 0. This graph starts not at a minimum, but very close to 1. So if I think of this as a minimum, how far off am I from the minimum? That would give me my phase shift. If I think of a sine function, okay, how far am I from this inflection point? Okay, how many days off is that? That will give me my phase shift. But then what does this mean? Why do we have this phase shift? Why doesn't the graph start exactly at the minimum? What is the reason for that? And there again, I'm going to let you think about that. I will have office hours for the rest of the week from 9 to 10, so if you want to check in about any of this, you are welcome to do that. I hope that this video helped you out a little bit more and that you have a wonderful summer. Take care, everybody.